Okay, so welcome everyone to QCamp 2021, our very first week-long online hosted quantum camp to teach what we know and what we find fascinating about quantum physics to you. First off, if you have any questions during the camp and encounter any technical difficulties or have questions of any other nature, please don't hesitate to write to us using this email address you see below, qcamp@quantumla.org. We, the organizing committee, will do our very best to reply as quickly as we can to solve whatever issue you may have. The organizing committee, that's Jenny, Pooja, Naresh, and myself. And we have, together with almost 30 other CQT volunteers, been working to put this week together for you to show you as many different aspects of quantum physics and of the people around it, what it means in terms of careers, what it means in terms of creativity, in terms of science, technological opportunities, and so on. So what you can see here are two pictures of the camp in 2019. Back then we were still having it, of course, we're still holding it in person, but fortunately technology has progressed. So despite us not being able to talk to you in person, we still tried our very best to make this as interactive as possible for all of you. And for that, we, on the one hand, use Zoom lectures, but we also want to have a platform for you all to connect a little bit and maybe meet some like-minded people. And for that, Pooja and Naresh have been putting together a platform called, or a platform on a platform called GatherTown, which has the function to offer you a space where you can walk around in a virtual character. And I think we noticed that that most of you have already been meddling with the platform. And using your characters, you can then basically interact with other people from the camp in this virtual chat space. We will be using this platform as much as possible, for example, during breaks and also to some extent during tutorials, so that you can interact and have kind of a more natural experience apart from just having 30 people in chat and windows superimposed in a Zoom meeting. So you might be wondering what you can expect from this week. We tried, for example, to admit as many people as possible to this camp, but it was still very difficult to admit all the students that were applying to the camp. So do we expect you to be the elite of everything, to know everything, to show us how sophisticated and advanced your knowledge is? Not really. What we expect from you is that you are brave. So every time you have a question or you have some thought that you would like to understand better or that you would like to elaborate on, we would like you to share this with us during the meetings, for example, using the Zoom chat. But we also would like you to be curious. You will notice that quantum mechanics is a very diverse field and one that attracts a lot of different perspectives, different motivations also to become experts in certain aspects of the field. And as PhD students, for us PhD students, it's also a continuous journey to understanding other people's perspectives and takes and interpretations of the field. As much as we hope it will be for you to, first of all, understand some fundamentals better, but then also to be open towards other people's understanding of these fundamentals and to discussions on things that are not even resolved at the current state of knowledge. So we would like you to be brave, to be curious, open-minded, and also to be social. Despite this camp being virtual, we have implemented ways for you to maybe get to know other like-minded individuals with whom to talk and maybe connect, and who you will possibly meet again once you commence your studies or at any later point in life. So take this opportunity. Feel free to ask us, the organizers and the instructors, any questions. And most importantly, despite this program being, we think, quite dense, it will definitely be, in a sense, positively challenging and hopefully enlightening. We want you to have fun. These are your holidays. It's amazing that you are so fascinated by the topic that you want to spend your holidays on a week-long camp. But this shouldn't be at the cost of you enjoying the insights that you can extract from this field. They might be different from what other participants find so exciting, but that's what's so wonderful about the topic, the diversity and in what aspects you would like to expand on. What you can expect this week is a wealth of different types of activities. Of course, we have Zoom lectures, and we will have an amazing lecture starting right after this introduction and after get together in Gathertown. But we also have prepared some panel discussions on the last day, some virtual lab tours so that you gain an insight into what research labs actually look like, and some interactive tutorials. We hope with this to offer you an as broad as possible range and feeling for the atmosphere that CQT brings with it, but also working in this field brings with it. And the rules the most important rules are quite minimal, but also quite fundamental. One is, and I think you are aware of this, please don't share the links and passwords with your friends. We tried to share as much of this material with people who cannot attend as possible. But in order to make this a personal and interactive experience for all of you, we had to limit the number of participants. So please don't share the links and passwords with your friends so that we can ensure that this is interactive. And the rules for interacting within the camp are, well, be respectful, be open-minded. We are all here to learn. That includes the PhD students who have spent hours on preparing the notes and the lectures for you. And you might discover much more by making sure that you have an interaction with people that includes everyone and that might actually surprise you with some new perspectives on topics. Okay, let me just quickly go over more or less quickly, go over the timetable and what you can expect this week so that you understand a little bit of the structure of the camp. We are starting right now with an introduction to the framework. So first of all, what is CQT? What is QCamp to us CQTians? And then how to use Gathertown so that you can make the most of this camp. We will have this followed by a socializing session so that you can get to know the other participants. And then at 11 a.m., we'll start with our first lecture given by Alex, who will talk about applications of quantum technologies. After a lunch break, we will start at 2 p.m. with our lecture that gives you the mathematical foundations or the mathematical tools you need to express quantum mechanics a bit more formalistically. So we will talk about complex numbers and linear algebra. That will be followed by a tutorial. We have put together some exercises for you to deepen your understanding of these mathematical tools. And during the tutorial, you will be able to go over them with TAs and ask any questions or resolve any issues, uncertainties that you might have with regards to the content. On Tuesday, we will finally delve into quantum physics. We will start with a lecture on qubits. We'll then continue with optical qubits, a more experimental take on and what you can actually do with qubits interacting with each other. We will then continue with the basics of entanglement and the teleportation protocol, one of the flashy examples of what quantum mechanics can enable. And we will then in the afternoon again offer you the opportunity to talk about the exercises that the lecturers have prepared for you under their guidance. This will be happening using Gathertown. On Wednesday, we will go into applications of quantum mechanics. Firstly, we will talk about the aspect of security, which I think many of you are very interested in, the idea of secure communication or of quantum key distribution, QKD. And we will then talk about one of the prominent platforms on which people are trying to realize quantum computation, namely cold atoms. Both of these activities are supplemented by a virtual lab tour. So one lab will be shown to you that is related to quantum key distribution, cybersecurity work. And the other one is actually the lab of the lecturers, Jaren and Kim, who will be talking about cold atoms and will guide you through their lab. So where they do all the magic. We will then have a break, and then have something following called preparation for Friday. And that means that we will send you 2 excellent articles that give you a really nice, comprehensive overview over the concepts that enable quantum computation and the different platforms that there are for quantum computation. You will study these by yourself. So we will send you these articles, and we hope that you will take the time to go carefully through them together with some prompt questions, so that we can have a nice discussion on Friday in a second lecture, where we will actually show you how scientific discussions here at CQT work, by having you all form small discussion circles, again, under the guidance of a CQTian, to resolve any questions or ideas that came from these articles. On Thursday, we will go into the more advanced topics of quantum mechanics. One is the Bell non-locality, and the other one is the Schrödinger equation. This more lecture-heavy content will be followed by something more fun and interactive, we hope, a lecture on cryptography, and then an activity, which we termed a cryptography scavenger hunt, where you will hopefully be well entertained, but more about that later this week. Now, besides offering you an insight into all the research that's being done about quantum and the foundations of it, we would also like to, on the last day, take some time to invite an external speaker, the head of a CQT startup, to talk about career advice, to talk a little bit about how his career panned out, and what you might be able to consider in your own choices on what to study, what to think about studying, what to dream of, how determined you should be already at this point to be a certain someone in 20 years' time. All these questions that are very difficult to answer when you only have teachers and family around. So we hope that the last 2 sessions on Friday will offer you a platform to resolve some of these questions, or at least gain some new ideas on how to answer them. And in the mornings, of course, we will introduce you the other extremely important platform for quantum computation, or for the onset of quantum computation, superconducting quantum circuits. So with this, we hope that we can satisfy most of your curiosity about this topic at the initial stage, and prime you to become more engaged in the field. And before we go now into the academic intricacies, let me just give you an overview over where we actually are. I mean, of course, you are at home, I suppose, but what is CQT? What is the institute that hosts this virtual space? CQT is an international research institute that was founded in 2007 and has some 200 members at the moment, including 70 PhD students and 24 PIs. PIs are basically people on a professor level who lead research efforts and supervise PhD students. What is quite amazing or quite remarkable about this institute is that we are sincerely international. You can notice that during lunchtime, sitting together with people from Brazil, people from China, people from India, people from Germany. I'm personally from Germany. Naresh and Pooja are from India. And because of this internationality, we have a very communicative atmosphere. And I think that's one of the core features of the Institute. This is, by the way, our director, Jose Ignacio, who's from Barcelona. So for a quantum or for a research institute, there is a balance that needs to be struck. There are basically 3 pillars to upholding it stably, ensuring that it is successful. One is, of course, the part about discovery. We are a research institute, so one of our prime interests is to discover new fundamental principles and satisfy our curiosity as researchers to advance science. But there's another, especially also in Singapore, pronounced interest in translating these discoveries into technology. How can we make this useful to society in the near future? These 2 aspects are then heavily supplemented by the idea of educating, because of course we can develop new tools, but it's extremely important also to inspire young people to, first of all, develop their intuition, so to lead to perhaps even a certain cultural advancement by understanding the world around us better, but also to motivate you to become experts and proficient and professionals in this field so that the field can continue to thrive. And QCamp is one of our core efforts, so one of our institute's core efforts every year to inspire and communicate what we find important about quantum physics and what we think are its core aspects. And we hope you will be able to take this with you from this week of activities. Now, quantum physics is, it seems like a simple term, quantum physics. You surely have some set of laws, and once you know the laws, you can do whatever with it. But the more you understand about this field, the more you realize, and that's the case with a lot of topics in physics, the more you realize that it's extremely diverse in its applications and in the ways you can engage in the field. There are theoretical physicists who have never seen a lab from the inside. There are experimental physicists who prefer to not sit at the desk for 2 extended periods of time a day. And there are computer scientists who also work on the mathematical intricacies of the topic and the implementation. For example, applied areas include quantum computation and simulation, so the effort of building a quantum computer. Then something like quantum communication, where you try to, again, ensure security through secure information distribution or secret information distribution. And then there's also the field of quantum sensing and metrology, where we build ultra-precise clocks and try to gain a better understanding of the environment by using extremely precise tools that use the laws of quantum physics. All this is then again tied into just a foundational curiosity, so foundational science, where we are just eager to find out more about the world around us and understand it better. So the diversity of this field is quite staggering, especially when you come to this, when you come to this cosmos for the first time. And that's why it's all the more so important that you are always eager to, that you are interested in talking to people and exchanging about possible experimental platforms for experiments and for your algorithms, or that you kind of build up a synergy between different factions within the quantum physics cosmos. So in quantum computing, for example, there are theoretical physicists who build algorithms that are of certain computational procedures that can be run on a quantum computer and that might make problem solving for certain problems faster. But then there are also the experimentalists who spend their days perfecting the art of building quantum systems on which these algorithms can be implemented. Here you can see, for example, the Cold Atom Lab and a lab that works with superconducting quantum circuits, 2 experimental quantum computing platforms. Then in quantum communication, we look at communication protocols, and we try to build systems that enable this secure distribution of information. We will talk about this in a later part of this week, as I mentioned. And then based on whether you want to, for example, communicate within Singapore, you can think about optical fiber-based information distribution, or you can think about satellite-based quantum key distribution if you want to go, if you want to span intercontinental distances. So what you see to the left is a fiber system, a chip that tries to implement chip-based quantum key distribution. And to the right, you see a satellite that was launched about, I think, 2 years ago by one of our teams here, the team of Alexander Ling, Professor Alexander Ling. And this system demonstrated entanglement in space for the first time. In such a small satellite. This is one of the cornerstones for building intercontinental QKD networks. And then lastly, there is the community of quantum sensing and metrology related researchers who develop ultra-precise atomic clocks to sense even astrological phenomena such as dark matter, or who build magnetometers or gravimeters for environmental sensing, for example, to analyze the resources, rare earths or oil below the surface at certain points on the planet. So it's quite a staggering diversity. And all this is actually supplemented by, as we mentioned, the strive to build some technology from it. And a good indicator of technology being built from this successfully are startups, because startups basically work with an idea, take this out of the lab, and try to make it something marketable, something that is of use to other people. CQT has so far spawned about 5 different startups and working in different aspects of quantum, so quantum computing, communication, and sensors. And to give you some idea on what it means to transition from a PhD from this academic world to a startup, what advantages that has, and what difficulties there are, how recommendable it is, and just to answer any other question you might have, we have a panel discussion on Friday that includes 2 former CQT PhD students, Aitor and Ulrike, who will be part of the panel and will be asked your questions together with our moderated questions to elucidate that aspect a bit more. So if we could ignite your curiosity and interest in the field after this camp, and you would like to stay in contact with us, lastly, we have an amazing administration team who makes sure that all of what CQT is accomplishing and what CQT is trying to do to involve the community here is always being published and accessible to anyone with internet, really. You can follow us on Facebook, on YouTube, or on LinkedIn, or on Twitter and Instagram to stay tuned on possible talks, publications, new developments, and announcements related to our center.